Okay, chapter 3, aldehyde and ketones. He said aldehyde and ketones contain carbonyl group. This is the carbonyl group. Carbon, double bond oxygen. This group called carbonyl group. Okay, carbon, double bond oxygen. Okay, an aldehyde contains at least one hydrogen atom bonded to the carbonyl group. He said the aldehyde must have at least one hydrogen bonded to this group. Okay, like this, one hydrogen bonded to this group. This it will be aldehyde. Okay, if both of the group are, it will be ketone. Just one of them hydrogen, it will be aldehyde. Okay, and if both of them hydrogen, it will be formaldehyde, formalin. Okay, the smallest ketone member, smallest يعني carbonyl group compound, the smallest aldehyde member. Now, whereas the ketones has two alkyl or allyl group bonded to it. That meaning the ketone must be two alkyl group or alkyl aryl or aryl aryl bonded to this carbonyl group. Okay, this carbonyl group. Okay, keep in your mind if I say to you carbonyl, meaning carbon double bond oxygen, carbonyl group. Okay, I hope it is clear this. And he said two structural features determine the chemistry and properties of aldehyde and ketone. That meaning to determine the properties of aldehyde and ketone, we have two something or two condition or two properties. The first one, the carbonyl group. Okay, the carbonyl group. This is the carbonyl group. Is sp2 hydrazide. That meaning this carbon is sp2 hydrazide, and we know sp2 meaning this atom surrounded by three group 1, 2, 3. Okay, if if there is any atom or any atom surrounded by three groups, it will be take any figure. It will be take the trigonal planar. That meaning we have a planar. This is a planar. Okay, it will be trigonal. Okay, look here, and he said making it relatively uncrowded. Okay, that meaning we have from the up and from the down, or from this side, it is open side. Okay, not crowded. That meaning it will be easy to attack from this side. Okay, the electronegativity oxygen atom, and look, we have here oxygen atom. That meaning the electronegativity oxygen atom polarize the carbonyl group. Okay, making the carbon electrophilic. That meaning if we have here oxygen atom, this oxygen atom high electronegativity, take the electron density from this carbon, making this carbon partially what? Partially positive, and the oxygen will be partially negative. Okay, that meaning if we have here nucleophile, the nucleophile it will be attack this carbon. Okay, because this partially positive charge. That the meaning here. Okay, the electronegativity polarize the carbonyl group, making the carbon electrophilic. Okay. As a result, he said, as a result, aldehyde and ketones, the aldehydes or the aldehydes and ketones react with nucleophile. That meaning the functional group of the carbonyl, it will be active for nucleophile. Okay, it will be active for nucleophile. Why active in nucleophile? Because the carbon, it will be partially positive and it will be active for the nucleophiles. The relative reactivity of the carbonyl group is determined by number of R group. He said, if anyone say to you, anyone is more reactive than other, the aldehyde or ketone, like that. Okay, that you have to think about the R groups. Okay, about the number of R groups, by the number of R groups bonded to it. And the answer, it will be as a number R groups around the carbonyl carbon increase. Okay, that meaning if we have more R groups, that meaning the reactivity of the carbonyl compound decrease, resulting in the following order of the reactivity. Okay, look to here. It will be have a formalin, we have hydrogen, and this it will be less reactive, R hydrogen, and this it will be RR for the ketone. Look from the left, from the right to left, increase reactivity toward nucleophiles. Increase reactivity toward nucleophiles. That meaning this is more reactive and this is less reactive. Okay. And from the left to right, increasing steric hindrance. Okay, that meaning if we have here two groups, it will be more steric effect than this, and this one group, it will be more steric than this. Okay, for this reason, this it will be more reactive. And if you can explain or thinking about by another words, you can say we have here two alkyl group. This two alkyl group donating, that meaning this the partially positive, it will be weaker. And we have this here just one donating group. This partially positive, it will be slightly stronger. Okay, and we have here, there is no donating group. That meaning this it will be strong partially positive. For this reason, it will be more reactive. This by another words. Okay, and this homework, he said rank the compounds in each group. That meaning this group A and the group B, in order increase reactivity. Look, increase reactivity toward what? Toward nucleophilic attack. That meaning anyone is more reactive for the nucleophilic attraction. This or this or this. Anyone, it will be the first one. Like this. Yes, this and this and this. Okay. Also, we have this here. 1, 2, 3.
هذا آخر واحد وبعدين هذا الأول واحد وبعدين اللي بالنص.
Okay, exactly. مضبوط. Okay, thank you. And here say look here, we have different compound here. We have one of them aromatic and one of them aliphatic. Okay, aromatic, aliphatic. Now, if you remember before that, if we have carbonyl group, okay, this carbonyl group is to be partially positive, and near from the benzene ring, it will be deactivated group. Okay, and it will be what? Orthopara or meta, it will be meta director. Okay, that meaning this deactivated group. Okay, if this deactivating group, that meaning the benzene ring is activate for this. Okay, by another one. This deactivated group, That meaning this group, it will be activate for this group. This is the meaning. Okay, but here no. Here we just have, and if you remember, all the carbonyl group, the carbon double bond oxygen, it will be deactivated by what? By resonance. If you remember that, we have resonance effect here. Okay, we have resonance effect, and we have, if we make resonance effect with the carbonyl here, it will be here on the, it will be positive on the benzene ring. Yes, full positive charge, full positive charge. If you go back to the activated, deactivated groups for the nitration or the reaction of benzene compounds. But here, no. Here we have inductive effect. Okay, we have here inductive effect. This donating, and this donating by resonance effect. Okay, now that meaning we have here different compound. One of them aromatic, and the other is aliphatic. Okay, here we cannot compare between of them by this, like this. Look, here we have aliphatic, aliphatic, aliphatic. Yes, that meaning we can compare between of them by an increasing R group or decreasing R group. But here no, here we are in different case actually. One of them is aromatic and the other is aliphatic. That meaning, if we think about the aromatic compound, we have resonance effect. Okay, and the resonance effect is strong, very strong than the inductive effect for the aliphatic compound. Then he said, what is the homework? He said, explain. It is actually not homework, it's resolved. Explain why benzaldehyde is less reactive than cyclohexane, okay, carbaldehyde. Okay, toward what? Toward nucleophilic attack. He said, why this is less reactive than this? Toward what? Toward nucleophilic attack. That meaning if we have nucleophile to attack this carbon, okay, this, it will be faster. The nucleophile attack this carbon faster than this carbon. Okay, here the meaning. Okay, exactly. And just I remove this. Okay. And he said, look to this word here. Actually, it is important words. He said the reactivity of aldehyde, depends on the electrophilic characteristics. Okay, character. That means dependent on the electrophilic characterization of what? Of the carbonyl carbon. That meaning he focuses or what? Or here the electrophilic. That meaning he focuses on the positive charge, the partially positive charge, on the positive charge. And he say, greater the electrophilicity of the carbonyl carbon, greater than the activity of the aldehyde. That meaning more positive charge, it will be more reactive aldehyde. Here the meaning, okay? He said greater the electrophilicity of carbonyl carbon. That meaning what meaning? Meaning greater is the reactivity of aldehyde. Okay. Now look to this and to this, and he said anyone is strong positive than the other. طبعا, of course, this partially positive charge, also this partially positive charge. Okay, but anyone, it will be strong partially positive or strong positive charge than the other. It will be more reactive. Why more reactive? It will be easy to attack from the nucleophile. All the times the nucleophile love to attack something strong, not something weak. Okay. Now, those aldehydes in which carbonyl group is directly attached to the electron donating group. That meaning this electron donating group, also this electron donating group, but this by inductive, this by resonance. Okay, has less electrophilicity as electron donating group, increase the electron density. Look, he said increase the electron density and carbonyl carbon. That meaning this, the aryl group, donating group, make the positive charge less what? less electrodensity.
سيدا أقول withdrawing هاكو هنجي ما خاندي هاكو هنجي ما خاندي مونا ما قلت withdrawing
withdrawing
سيدا
other withdrawing but other donating.
أودتي.
Okay يعني هكا look, one of them, if you have two parts, this part and this part, if this part withdrawing, that meaning already this donating. Okay, if you say this donating, that meaning already this withdrawing. I keep that, I keep take it. Okay, تكشتي عنها. Okay, I hope you understand. Okay, yes, the aldehyde group is withdrawing, but that meaning the benzene ring, it will be donating. This withdrawing with donating. Okay. Whereas in case of electron withdrawing group, the reactivity is enhanced. Okay. The explaining for this equation, he said in benzaldehyde, okay, in benzaldehyde, this is the benzaldehyde compound, the carbonyl group is attached to the benzene ring. Yes, we know that. The benzene ring being electron rich delocalized. Okay, that meaning we have resonance here, and you know the resonance. Okay, is electron through resonance and form double bond between the carbon of the benzene ring and the carbonyl carbon as here, as shown below. Look, this double bond, it will be open to make here double bond, and this double bond will be open on the oxygen, give us the first resonance figure. Okay, this is the resonance figure. Look, before that, this carbon is partially positive. Okay, before that. Here, the carbon, no, it is not partially positive. It will be equal. The partially positive and the positive, it will be removed in the benzene ring. Okay, that meaning before that we have here partially positive, but because the resonance effect, the partially disappeared. Okay, that meaning this carbon now is unreactive toward what? Toward the nucleophilic reaction. Okay, that meaning the resonance effect make the nucleophilic attraction to this carbon decrease. Why decrease? Because the resonance. Okay, because the resonance. Now, the resonance decreased, like he said also, the resonance decreased the electrophilic characters of the carbon, of the carbonyl carbon. Okay, that meaning before that we have positive charge or partially positive charge. Now there is no partially positive. Okay, making it less reactive. While in case of the cyclohexane carbaldehyde, here, the second one, yes, here for this compound, no such resonance. We don't have any resonance here. Okay, that meaning already we have partially positive here at all the time. Okay, at all the time. For this reason, it will be more reactive if you compare this compound with this. It will be more reactive. Okay. Why? Because we said before that the benzaldehyde has resonance effect. The resonance effect make the electrophilic characteristics of the carbonyl less than the other compound. Okay, and you can write the resonance, and it is clear to show we have here partially positive, but here we don't have any positive charge. For this reason, it will be less reactive. Okay, this I told you before that we have two different compounds here. This aromatic with resonance effect, and this aliphatic with inductive effect.
دكتور
بله.
ياسين أجاشتم كابوشي أو لسه رياكتيف.
Oh, okay. look,
سيدة
look.
ما درستها ما بيجنش بالريزونانس إفكتي
بس نا بس
والد كت ليس يعني قالك ستيبل
stable. No,
أريش بال
no, we don't talk about the stability here. Okay, يعني look, if you talk about the reactions and you have, he select the reactions actually, okay? He said not general reaction, he said nucleophilic attack. Just the nucleophilic attack. Because we have electrophilic substitution of the benzene ring. Bromination, alkylation, acylation, yes? And he said the nucleophilic attack here in this equation. And if you have here nucleophile, look, if you have here nucleophile, okay, if you have here nucleophile, the nucleophile, it will be attack any part of this compound. Where's the positive? Where's the partially positive? Yalla, you told me, where's the partially positive?
Carbon.
Yes,
Carbon.
just this carbon. Why? Because this carbon directly bonded to the oxygen. Oxygen highly electronegative, it will be partially negative. Carbon will be partially positive. And all other carbons, all other atoms is equals. Okay? The same thing here. If you want to explain about the nucleophilic attack, this nucleophilic attack, that meaning you have nucleophile. The nucleophile, it will be attack the benzene ring? No, impossible. Why? Because the benzene ring, high electronegativity. We have 3 pi bonds. Okay? High electronegativity. That meaning it is impossible negative to attack negative. Okay? That meaning where's the positive or partially positive? Also on the carbon, on this carbon. And if you want to compare this partially positive with this partially positive, anyone is strong partially positive than the other. This here, the positive charge, or here the positive charge. Okay. If you want to explain between of them, no, this it will be a strong positive charge than this. Why? Because this, the resonance effect, delocalize the positive charge on the benzene ring. If we say delocalized, that meaning it will be more stable. Okay? If you say more stable, that meaning it will be less reactive. As you said, the resonance make the compound stable. Okay? That meaning the resonance here, what is the working of resonance? The working of resonance here disappear يعني ينشر, okay, the negative charge or the partially charge, okay, from the carbon to all the benzene ring. But here no, the partially positive charge, it will be just there is no any delocalization. It will be stable on the carbon and ready to attack from the nucleophile. Okay, you understand? Okay, I hope you understand this. This is the meaning. Okay. But in general, if I say to you, anyone is more stable than the other, this or this, no, just in general, yani. If I say to you, any compound will be more stable, I don't select the reaction, I don't select anything. Okay, you will be say benzaldehyde is more stable than this compound, the cyclohexancarbaldehyde. Why? Because this it will be has resonance system, and this without any resonance system, this it will be more stable than the other. It will be right. Okay. But if the question select for you he said toward nucleophilic attack, just nucleophilic attack. Okay, that meaning we have nucleophile. The nucleophile, it will attack something positive. Okay, why this positive is more here is strong than this compound? You have to explain all this from there, and you have to write the resonance structure. Okay, until your answer to be complete, يعني جواب كامل. Okay, now. Here we had naming aldehyde طبعا also by IUPAC system. Okay, naming aldehyde by IUPAC system. We will take aldehyde and then ketone. And here in IUPAC system, aldehydes are identified by suffix. Look, by suffix added to the parent name of the longest chain. Okay, that meaning we have the parent name يعني الأصل. Okay, the root name, we say the root name, the parent name of the longest chain, and then we will add the suffix at the end of the name. And we have two different suffixes. He said we have two different suffixes. Okay, depending on the compound, it will be cyclic or acyclic. Okay, depending on the whether CHO group is bonded to the chain or ring. Okay. The first one, the name an aldehyde using IUPAC system. Number one, if the aldehyde group, طبعا طلب CHO, the مختصر for aldehyde group, CHO. Okay. If the aldehyde group is bonded to the chain of carbon, that meaning look like this. This aldehyde group bonded to the chain substituent on the carbon chain. Find the longest chain containing the aldehyde group. Where is the longest? 1, 2, 3, 4, or 1, 2, 3, 4. Okay, both of them is right. And change the E ending of the parent alkane. For example, hexane, propan, butane. ما ندوما هيك E هيا. Okay, change the E ending of the parent alkane to the suffix al. Hexane, hexal. Propan, propal. Butane, butal. That meaning this al refer to the aldehyde group. This al here refer to the aldehyde. It is coming from aldehyde. Okay, this here. Al, aldehyde. Aldehyde. Al, that meaning it's referred to the aldehyde compound. And if the aldehyde group here said if the aldehyde group is bonded to the ring, naming the ring and added the suffix carbaldehyde. That meaning we will give the name for this cyclohexane, cyclobutane, cyclopropyl, cyclonone, cyclodocan, anything, and then at the end we will be added carbaldehyde. Okay, carbaldehyde. يعني if my question convert the name to the structure. Okay, convert the following names to the structure. If you see at the end carbaldehyde, that meaning this carbaldehyde meaning it is cyclocompound, not open chain. Okay, and if you see al at the end of the name, that meaning it will be aldehyde open chain, not cycle. Okay, this again, this for open chain, يعني acyclic compound. This for cyclic compound. Cyclic, acyclic. Okay. It is clear this, yes? Number one. And number two, number the chain or ring to put the CH group, CHO group, the aldehyde group at the carbon, number one. Okay. But omit this number from the name, apply all, and then apply all the other rules for the IUPAC system, the name of the substituent, the number of the substituent, hyphen, comma, all other rules. Okay. Look again here. Find. Okay. Find. He said here. Find name of the longest chain. That meaning we have 1, 2, 3, 4. Okay, 4. It will be butane. Okay, it will be butane. Now, a butane, but we have here the aldehyde group. It will be what? It will be just change the E to the L. It will be butanal. Butanal. خلاص. هذا the name of this compound. But we have what we have. We have two substituents here. We have on the carbon number 2, this 2, because this 1, 2, we have 2 methyl. Also we have 3 methyl. That meaning it will be 2, 3, here, 2, 3, dimethyl butanol. Okay, this is the name. Look, 2,3-dimethyl butanol. Butanol meaning it is this al. It will be not cyclic compound. It will be open chain. Number 2, look to this compound number 2. We have here hexane. Hexane, it will be cyclohexane. This cyclohexane. Okay, cyclohexane. Don't say cyclohexanal. هكذا تقولي cyclohexanal خلطة. Because it's a cyclo compound. Okay, cyclo compound. That meaning it will be has here carbaldehyde. Okay, carbaldehyde. It will be cyclohexane carbaldehyde. Okay. Now, all the time CHO it will be on the carbon number 1. All the time this it will be number 1. Okay. Now we have ethyl on the carbon number 2. It will be what? It will be 2-ethyl cyclohexane carbaldehyde. Okay. 2-ethyl cyclohexane carbaldehyde. Look here, carbaldehyde. Okay, it is related with cyclo here. Cyclo, because a cyclo, it will be carbaldehyde. Okay, here al, that meaning we don't have any cyclo here. Okay, do you understand this? Okay, any question? No question. Okay. Give the name for each aldehyde. Okay, you have this aldehyde, this aldehyde, this aldehyde. طبعا easy compound. Write the name for this compound. Okay, this is for you. And also the reverse question. يعني عكسي, I will give you the name. I want from you to write the structure. طبعا طلبة, this type of question easy from this. If I give you the name, give me the structure, it will be easy for you. If I give you the structure, write the name. Okay, I know this. You have here, write just the structure. Give the structure corresponding to each IUPAC names. And we also have commercial common names for the aldehyde. A common name for aldehyde is formed by taking a common part for the alkyl name and adding the suffix aldehyde. Okay, this is formaldehyde, methanol. صح methanol IUPAC name. Formaldehyde. Okay, formaldehyde, it is a common name. Also, we have another name for this compound. It is the formalin. Formalin. Okay, formalin. This ethanol IUPAC name. The commercial name is acetaldehyde. Acetaldehyde. Why? It is coming from acetic acid. You know the acetic acid CH3COOH. Okay. It is coming from acetic acid. We say acetaldehyde. Acetaldehyde. Okay, acetaldehyde. And this, it will be benzene carbaldehyde. طبعا this benzene carbaldehyde, it will be benzaldehyde. This is the common name, benzaldehyde. Okay, طبعا طلبة common name, there is no special يعني rules. Just it will be memorized يعني the names. Formaldehyde, acetaldehyde, benzaldehyde. There is no special rules. And then he said here from you, you can use this. Look, this carbon number 1, 2, 3. We can use numbers 2-chloropropanyl. Also, for the most common name, they used alpha, beta, gamma. Okay, this the carbon near from the carbonyl group. It will be alpha. This is the alpha, and this is the beta, and this gamma. It will be like that. Okay, that meaning you can use number or you can use alpha, beta, gamma. But for IUPAC system, use number is easy for you. And some common names, they used alpha, beta, gamma. Okay, like this alpha chloro propanoic aldehyde. Okay, propanoic aldehyde. And this beta methyl varyl aldehyde. This we said varyl aldehyde. Okay, look, it is common names. Okay, he said what meaning varyl aldehyde. Okay, and he said here phenyl acetaldehyde. Phenyl acetaldehyde. Okay, but the IUPAC name, it will be phenyl ethanol. This ethanol, and we have phenyl bonded to the ethanol, it will be phenyl ethanol. Okay, phenyl ethanol. Naming, طبعا here also naming ketone by using IUPAC system.
سيدة أم في السيريج بيركن
No, صح. If you want, you can use the IUPAC system or IUPAC system. طبعا يعني by the system. Okay. Have a common name إجباركن يعني أو for you. Okay. But if I give you this compound, I want from you the name. You can use the IUPAC system. Don't go to the common name. Okay.
Okay.
IUPAC system is easy than other names. Okay. The name of a cyclic, look, he said a cyclic ketone. That meaning we have open chain, okay? Open chain. By using IUPAC rule, IUPAC system, he said also find the longest chain containing the carbonyl groups and change the E, hexane, E dumahik ya yamana, change the E ending of the parent alkane to the suffix on. Hexane, it will be hexone. Okay, if you look to the last the name on, that meaning it will be ketone. It is come from ketone on. Okay, this ketone. Okay, ketone. And number the carbon chain to give the carbonyl carbon the lower number. Okay, that meaning the functional group of the carbonyl group, it will be take the lower number. Apply all other rules for the IUPAC system. With not cyclic. With cyclic ketone, numbering always begin at the carbonyl group. Okay, at the carbonyl carbon. That meaning the carbon of the carbonyl group, always it will be take number 1. But this number 1, talaba, is usually omit. We don't write number 1 on the name. Okay, it will be usually omit from the name. Okay, the ring is then numbered clockwise or anti-clockwise. يعني وكي عقرب الساعة or عكس عقرب الساعة to give the first substituent lower number. Okay, we know this rule also. We know this rule. That meaning this. This, look to this carbon for the carbonyl group, it will be take number 1. Now, we said 1, 2, 3, 4 or 1, 2, 3?
1 2 3.
Yes, it will be 1 2 3. يعني وكي عقرب الساعة قال عقرب الساعة. Okay. And this, no, this it is open chain. We'll take 1 2 3 4 5 or 1 2 3 4 5. No, it will be 1 2. Take carbon for the carbonyl group, it will be take lower number. Okay, it will be no, it'll take the lower number. That meaning this it will be 1 2 3 4 5. Okay, 1 2 3. That meaning on the 3, on the carbon number 3, we have methyl. Okay, on the carbon number 3, we have methyl. That meaning it will be 3 methyl. This 3 methyl. Okay, pentanone, pentanone. Okay, where is the carbonyl? Carbonyl on the carbon number 2. That meaning it will be 3 methyl 2 pentanone. That meaning this 2 refer to the position of on. Where is the on? On the any carbon, the on. The carbonyl group. Where is? It will be on the carbon number 2. Okay. 3 methyl 2 pentanone. That meaning this 2. This 3 refer to the position of the methyl, yes? And this 2 refer to the position of the carbonyl group on. Where is the on? Okay, now, for the ring, Cyclohexane, it will be cyclohexanone. This cyclohexanone. Okay, cyclohexanone. We don't write one cyclohexanone. Why? Because all the time, the carbon of the carbonyl, it will be tech number 1, and this number 1, we don't write it on the name. Okay, we don't, the number 1 will be omit from the name. Okay, now we have substituent here. We have this, we have this. We have this isopropyl, we have this methyl. Okay, that meaning 3 isopropyl, 4 methyl cyclohexanone. Yes, easy, yeah? Okay, is it clear? No question? No question, طلبة؟
واضح أستاذ.
لا سيدة.
بلى؟
واضحة سيدة.
واضحة، الحمد لله واضحة. Okay. Look, he said the homework, this for you. Give the name, give the IUPAC name for each ketone. You have these ketones, okay? Write the structure, the structures, and give the name. Okay, write the name for this compound. This for you. Also, we have also the common name for the ketones. Okay, commercial name. Look, most common name for the ketone are formed by naming both alkyl group. It is, he said they use system, it is like ether. If you remember for ether, we said ethyl, methyl, ether. Okay, the same thing here. They use it for the commercial name for the ketone. They said ethyl, methyl, ketone. Okay, by naming both alkyl group on the carbonyl. Okay, and arranged by alphabetically. Anyone to be methyl, this methyl, ethyl. That meaning ethyl, methyl. Okay, and put it word ketone. This is the ketone. Okay, this is the ketone. This methyl, ethyl, ketone. Okay, طبعا with the space. If you look, we have here space. We have here space. Okay, this space is not IUPAC system. The IUPAC system, look, the IUPAC system, they don't use a space for the IUPAC system. Okay, it is one of the rule for the IUPAC system. If you remember, we don't use the space when you write the name by using IUPAC system. But for the commercial name, for the common names, okay, no problem. They use a space. Okay. And this, the acetone, dimethyl ketone, like this. Also this, methyl phenyl ketone, diphenyl ketone. Okay, it will be like that. Okay, acetophenone. Look, it is commercial name. Acetophenone. This is the acetone. Acetone. Acetone is ketone, طلبة. أو acetone. It is a strong solvent to remove some paint. They use it. And this acetophenone or this benzophenone. Okay, this is clear, yeah? Okay. This, the names, look here. He said 3-bromo, 3-bromo here, 1, 2, 3, 3-bromo acetophenone. This is the acetophenone. Okay, here meta-bromo acetophenone. Acetophenone. طبعا here for the acyclic compound 2-methyl 3-pentanone. Okay, 2-methyl 3-pentanone. The common name ethyl isopropyl ketone. This for this ethyl, this is the ethyl, and this isopropyl ketone. Okay, now just folks, if you have on, that meaning this, it will be ketone compound. Additional nomenclature facts for the aldehyde and ketone. He says sometimes acyl group, this is the acyl group, okay, in general acyl, we said acylation must be named as substituent. Then To name an acyl group, take either the IUPAC or the common parent name and added the suffix wal, okay, ul, or oil. The three most common acyl groups are drawn below. This formyl, okay, this formyl. It is from formaldehyde, formyl. This is from acetaldehyde, acetyl. Okay, this is from the. He said this group is benzoyl. طبعا طلبة you have to memorize this أو حافظة طلبة formyl, acetyl, okay, benzoyl. This acyl group, this acyl group, all this acyl group. If you remember, we can if you have benzene ring and we want to make acylation for the benzene ring, we use this part with the chlor or with the brom, okay, and AlCl3 or AlBl3 and this and this. That meaning in general this acyl group, this acyl group. But we have different type of acyl group. The smallest one, this formyl, acetyl, benzoyl, okay, not the big one. Okay. And he said the compounds containing both carbon-carbon double bond and aldehyde are named as enal. Okay, that meaning this en from alkene and this al from aldehyde, it will be enal. Okay, it will be enal. Look here, to have dimethyl, we have dimethyl here. Okay, butanal. That meaning we have aldehyde will be take number 1 all the time. And where's the en? It will be on the carbon number 3. It will be 3-butanal. Okay, that meaning this 3 refer to the position of the en of the alkene. Where is the alkene? It will be started from the carbon number 3. Like this also. Look, for methyl, we have here for methyl 3. We have here 3 pentene and on ketone. Where's the on ketone? It will be started from the carbon number 2. Where's the alkene? It will be started from the carbon number 3. That meaning 3 pentene, 2 on. 2 on. Look, it's a small compound. This is a small compound, but for you, I know the names is slightly complex. Okay, you have many parts here. You say, okay, 3-methyl is easy. Okay, for you. Okay, we have ketone. Ketone, it will be started on the carbon number 2. That meaning it will be 2 on. And we have in alkene, it will be started from the carbon 3. It will be 3 pentene, 2 on. Okay, but we cannot use a 3-2 pentenon. Okay, one of you will be asking me why we don't write pentenon. Okay, pentenon. That meaning we have in on. We have to refer to the position. Where's the on? Where's the alkene? Okay, the alkene will be started from the 3. That meaning it will be by slash by hyphen. Sorry, and 2 on. Okay. I hope it is clear for you. This name is slightly complex, I know, but if you try it to write it some like this compound, and it will be easy for you. Okay, write it on the paper 2, 3, 4 times and thinking about how to write the name of a compound with carbonyl and alkene. Look to this compound. Look, this compound for the first time maybe it will be complex for you. Okay, we know we take it before that. This group, okay, this group is benzyl. We know that, we take it before that. And this group is benzoyl. Okay, this group is benzoyl. This group here. Okay, we have benzyl, we have benzoyl. Okay, that meaning what remaining? Just remaining pentan, cyclic, and ketone. Okay, that meaning it will be pentanon. Okay, on the carbon number 2, this carbon number 2, what we have? We have benzyl. On the carbon number 3, we have benzoyl, that means it will be 3 benzoyl, 2 benzyl cyclopentanone. Okay, cyclopentanone. This is the name for this compound. And the other is easy. This is easy for you. Okay. And look, secondary butyl ethyl ketone. Okay, he used he used the IUPAC system or the common name here?
Common name.
Yes, he used the common name here. Okay, secondary butyl. This is the secondary butyl. This meth ethyl prop butane. Any butane, this secondary butane. Okay, secondary butyl. Secondary butyl ethyl ketone. Okay, and here he said carbonyl. This is the carbon. It will be on the number 1. This number 1. And the alkene also functional group, it will be take the less number. Okay, don't write 1, 2, 3, 4, 5. No, it will be 1, 2, 3, 4, 5, because this functional group, alkene, functional group, but this is substituent here. Okay, that meaning it will be 1, 2, 3, 4, 5, 6. Okay, on the position, on the carbon number 6, we have dimethyl, 6 dimethyl. Okay, we have cyclohexene. Look, cyclohexene. Okay, where is the ene? Where is the ene? On the carbon number 2. That meaning it will be 2 cyclohexene. It will be like this. The name. Now, the other, this. Look, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. That meaning on the carbon number 5, what we have? We have alkene. This ene, 5 ene, and we have al all the time. It will be on the carbon number 1. We don't write the number 1 here. Just 5 hexenal. This is the 5 hexenal, and we have substituent here, the ethyl. 3 ethyl, 5 hexenal. It will be like this. Para-ethyl, look this. Para-ethyl, this is the para-ethyl. Aceto, this is the acetophenol. This is the phenol. Para-ethyl acetophenol. Okay, this ketone. Para-ethyl acetophenol. And this the same thing here. 1, 2, 3, not 1, 2, 3, 4. 1, 2, 3. That meaning on the carbon number 3, we have a butyl, tertiary butyl, 3 tertiary butyl, 2 methyl cyclopentanone. Okay, cyclopentanone. This 1, 2, 3, 4, 5, 6, 7, 8. It will be 5 ethyl. Yes, this we have here ethyl. This is the ethyl. 4 methyl. Yes, we have methyl here. Okay, and we have octanone. Where is the carbonyl? On the carbon number 3. That meaning it will be 3 octanone. Okay, and the final one, the same thing. We have 1, 2, 3, 4, 5. 5, that meaning is pentane. Okay, pentane, ketone, yes, pentanone. Okay, where is the ketone? It's on the carbon number 3. It will be 3 pentanone. Aba 3 pentanone. Aba 3 pentanone. Okay, we have substituent. Yes, we have substituent. We have 1, 2, 3, 4. Identical substituents, identical methyl group. That meaning 2, 2, 4, 4, tetra. Look, tetramethyl 3 pentanone. Tetramethyl 3 pentanone. And this homework for you. Give the structure corresponding to each name. That meaning you have this name. Write the structure. This for you.
سيدة أبا پارا بایو پاک نیم داچال نویسین.
كيش؟
أبا پارا بوا.
بارا وكي أفا صح يا أبا مانا بارا مانا بنزيننج أفا.
بله.
يا أفا فيري موقع أول أفا أورثو ميتا بارا.
نه سيدة مقصدم آیو پاک نیم داچال نویسین.
أيوباك نيم؟ يا أفا أيوباك نيم.
سيدة.
أفا نوكا أيوباك نيم أفا. بارا إيثايل أسيتوفينول. هكا بارا تنبت بارا بفيسا 4 إيثايل أسيتوفينول.
درست سيد.
اوكي بارا 4 والميتا 3 والاورثو 2. 1 2 2 3 4 اورثو ميتا بارا the same thing. اوكي
سيدا بس نو في بيجابة
بله
أفا نوكيا بارا أفا ديش سيبي
افا
هيك
بارا
تقول بقى
إيه؟
بس في بيجابة نو في سيدا
ها انا بيبي صح كده افا acid this is methyl yes or this is phenyl this it is coming from aceto okay this aceto يعني this aceto group and this is phenyl okay now both of them is ketone acetophenone they said acetophenone this is phenyl and this is methyl okay this part is coming from the acetic acid he said acetone or acetal okay they say acetophenone para-ethyl acetophenone or you can say like this look this group just for you this what is the name of this group
أسيتال
yeah acetyl this acetyl okay خلاص acetyl تمام okay
تمام.
now take we have acetyl and we have ethyl acetyl ethyl okay that meaning it would be para-ethyl واضحة معنا para-ethyl acetyl benzene
لا
okay you can write here or for ethyl acetyl benzene this acetyl or this ethyl okay
تمام وصل درست يعني
وصل درست المهم نافك درست يعني حسب الايوباك سيستم اوكي
تمام درست
and here physical properties for aldehyde and ketone طبعا boiling point yes boiling point he said take it this boiling point melting point and take the solubility I know that okay four compounds of comparable molecular weight that meaning if you have this compound this is alkane this aldehyde and this kahol if you want to compare between of them and all of them is slightly similar molecular weight this is 72 also this 70 this 74 okay there is no different molecular weight between each of them that meaning he said here for the compound compared to molecular weight boiling point and melting point that meaning the physical properties okay the stronger he said here the stronger intermolecular forces the higher boiling point okay now this we have just van der Waals forces okay this van der Waals forces this we have van der Waals forces okay we have dipole interaction why dipole interaction because we have carbonyl group carbon double bond oxygen partially positive partially what negative that meaning it will be happen dipole interaction for alcohol we have van der Waals forces also we have dipole interaction also we have hydrogen bond okay that meaning anyone is needed more energy to separate the molecular between of them
دموهيكي
yeah دموهيكي why سي قوة ده van der Waals dipole hydrogen bond and then it will be this and then it will be this that meaning this need more energy this need low energy if you look to the boiling point it will be 36 the boiling point يعني هكا تدانا بدستيتا وصلت بقرة the boiling point دي تشيبا دي تبخر okay it will be evaluated on your hand okay but this no this it will be need 118 degree okay to be boiled look to the difference it is very big difference okay this because we have here additional forces between the molecular is the hydrogen bond okay Now solubility, we know he said aldehyde ketone, it will be soluble in organic solvent. Why? Because it is organic compound, and here less than 5 carbon may be dissolved in H2O, more than 5 carbon it is slightly or non-soluble in the H2O. Okay. Properties of aldehyde and ketones. Look, he said here the properties. The preparation of aldehyde and ketones. We take the properties here. Okay, preparation. Preparation of aldehyde and ketones. Okay. طلبتك ايش حتى بيري معنا؟ مشكلة هيا مشكلة بالسيارة هيا طلبة؟
لا سيدة واضح.
اوكي.